Welcome to VW 6.4. Today we'll be continuing our study of rational functions. So to start, I put some steps out here for you. These are the typical steps for graphing a rational function, and then once you get good at it, you'll be able to do it just from your head. But for now, let's follow the steps I outlined. So A is going to be find the domain. So focus on the bottom right here and think about what x cannot be. So I can see that x cannot be 2 and negative 2. So that's where we'll start. Now for x and y intercepts, hopefully you can do this in your head. The x-intercept is 1. Look at the top and think about what should make that 0. And the y-intercept, I can see that should be a quarter. And I'm plugging in 0 here, and you can see that's 1/4. Next one, vertical asymptote. So let's put VA. If I look at this thing, that's x minus 1 over x plus 2, x minus 2. Note that nothing can be simplified, so just take the bottom. X should equal 2 or negative 2. For D, we have our horizontal asymptote. Since the bottom degree is larger, that's going to be y is equal to 0. And now we're going to check if it crosses the HA. So I really want you to highlight this. This is really, really important. It says find, if any, where the graph intersects the HA, which means a graph can cross your horizontal asymptote. A lot of people think you can't. That is not true. A horizontal asymptote is not a restriction. It's merely saying what the graph is going to approach, versus a vertical asymptote is a restriction. So to check if it crosses, all you do is you just wonder, does f of x equal the HA value, like that. So we're going to write down, will it cross your HA? Grab your function, x minus 1 over x squared minus 4, set it equal to 0. We can actually solve this. Let's multiply by x squared minus 4. X minus 1 equals 0. And look at that. X equals 1. Therefore, it will cross at x equals 1. Okay, so now that we have that, that's like the main information we need for this. So now, let's go to our graph here. I'm going to start by actually doing the intercepts. So we have 1 1/4. So I'll label 1 right there. That'd be 1 0. And let's say 1/4 is like right here. And then we have a vertical asymptote at 2 and negative 2. So we'll just scale that out. Let's put our dotted lines down. I have a horizontal at 0, so I'll put that down too. And that's pretty much all we know. Now for the graph, we know that this connects here. I'll make that a regular line. Because it has to. There's nothing else that can happen. And we know it's going to cross through the HA, because if you look right here, I can see that's x minus 1. And note that's to the first power, which means it does have to cross through. So that has to look something like that. And I know that this actually has to keep going up because there's no other intercept. The only x-intercept is 1, so this thing couldn't come down. That'd be impossible. It has to just keep going up. Now to get the rest of it, all we're going to do is plug in some points. So this is 3, negative 3. Plug in 3 to this thing right here. We get 3, 2/5. So let's say that's like over here. And what's really cool about plotting that point is that we know what has to happen. You can't cross a vertical asymptote, and while you can cross the horizontal, this work right here proves it will only cross at x equals 1. So in fact, I'll add that word. It will only cross. That's important. because that means you can no longer cross the horizontal asymptote. So the graph is just going to do this. Just approach your asymptotes, and that's really important to understand. So on the other side, we do the same thing. Plug in -3, you get -4/5. So I'll plot that over here somewhere, and same thing. Notice how just a rough sketch. It doesn't have to be perfect, and that is a good graph. Let's try one more. So now it says find the domain. Notice how it's all the same steps. I'm going to draw a box to organize all the information for us. And as we get to more graphing, I'm going to like putting a box down just to keep everything organized. So domain, I can see that x can't be 1. The x-intercept, -2. Y-intercept, -4. And again, the x-intercept comes from making the top 0. So I just thought in my head, what makes that thing 0? And the y-intercept, I plug in 0 here, so I get -4. And our vertical asymptote. So the top, I can factor, but notice how nothing cancels here. So there's nothing I can really do with that. So I'm just going to write the vertical asymptote is x equals 1. A horizontal is y equals 2. Since these powers are equal here, you just grab the coefficients. So it's just 2/1 like that. And now we're going to check, will it cross the horizontal? So grab your function, 2x plus 4. Actually, I'll move this on the side. 2x plus 4 over x minus 1, and make that equal to the HA value, which is 2. Let's multiply everything by x minus 1. So 2x plus 4, that's equal to 2x minus 2. Notice those cancel. You get 4 equals -2, which clearly is impossible. Therefore, this will not cross your HA. So I'll put no cross. Now we can graph. So my x-intercept and y-intercept, let's put that down. -2, and 1, 2, 3, 4, -4. We have a vertical asymptote at 1 and a horizontal at 2. So let's sketch those. Put those down. And now let's connect our lines. So I know these are going to connect here. I can't cross my vertical. And again, this is very valuable information right here, this whole thing. You can't cross your horizontal, so this is just going to approach it like so. Now plug in a point. Let's say plug in 2. That's going to be 8, so we'll just estimate up there. And you have to understand that's all you need, because this dot tells you that you have to approach your vertical asymptote like that. So that's just going to approach it. And that's going to approach your horizontal like that. And that's your final graph. Okay, so good luck on your homework questions. Let me know if you have any questions in class.